Okay, great. So welcome back, everybody. For those of you who are new, just remember the ground rules. We treat this just like a regular seminar. So if you have a question, just unmute your mic and jump in like you would normally. Is Pavel in the chat room, Andrew?
He was.
Was he going to join us?
I think Pavel, are you here? Yeah, he was. I saw his name pop. There he is.
Okay, great. So for smaller questions, you can feel free to ask them in the chat. They just do a chat to everybody, and maybe Pavel can weigh in also. And then we'll of course have time afterwards. We'll leave the stream open, and we can ask more questions and give more comments. Okay. So otherwise, Andrew, take us away.
Okay. Thanks a lot. Thanks for having me. And this is joint work with Palko Kosti, who is the economist there at the Federal Reserve Bank of Cleveland. These are my own opinions. They have nothing to do with the Board of Governors or the Federal Reserve System at all. And the same goes for Pavel. Okay. So this is going to be this is a search and trade paper, right? It's mostly a theoretical model. And then we are going to sort of calibrate to the US and China at the end. So why are we interested in this sort of model? Basically identifying and engaging overseas buyers. We know it's a prevalent and costly barrier to exporting. Okay? So our goal is to formalize this costly search for partners. We are going to take off-the-shelf, fairly straightforward models in order to make it as transparent as possible. We're going to try to get analytical solutions for everything that we can. So we just look at expressions and see how search frictions affect economic aggregates. It's a GE model, and the goal with, we're going to pare everything down. Our goal is going to be able to make statements about general equilibrium quantities using this pencil and paper framework. We're going to quantify the effects of search frictions, adding search frictions to a model on trade flows, consumer welfare, and trade elasticity, and a couple other measures like the intensive extensive margins for the United States and for China in 2006, using data in 2016. And then we're going to do a couple experiments based on that calibration. The main results of the paper are that when you put search frictions on the output side, so all these frictions on the output side, goods market frictions in a model, you get a concept of unmatchedness, right? So some endogenous fraction of producers in this model, which we'll label, those will be our exporters, are going to be unmatched, right? So that's in the labor literature, right? You put search frictions in a model, you get unemployment. We're going to have a very similar concept, and that is going to vary endogenously. When you then, using our calibrated version of the model, we're going to show that if you reduce the international search costs, so that the costs that producers face when they're looking for a partner in a foreign country, to the domestic level, so the same search costs that they would face if they're looking in their home country, you would get an increase in US welfare by 5.6% and an increase in Chinese welfare by 4%. Right? So the magnitudes of reducing search frictions, reducing international search frictions, is going to be substantial. We're also going to show that search frictions attenuate the ex-ante welfare response to tariffs by about 85%. That the trade elasticity increases, right, from negative 3.2 to negative 5.5, and that the trade elasticity with respect to search costs, so if you increase search costs by 1% in our calibrated version model, trade flows decline by 70 basis points. Okay, that's the basic structure here. Sorry, we're related to a couple different strands of literature because we're bringing together these labor search tools basically with some standard trade models. In general, we're going to bring together like the Mortensen, Diamond Mortensen, Pissaridi style search models with the Mellitz, Chenet style trade model. When we match this to the data, we're going to use mathematical programming with equilibrium constraints so that we solve the model and minimize the distance between the model and the data at the same time. And some of our selection of moments are inspired by, Armstrong Korn, Michelin Saez, some of the macro literature, Petrosky, Wasmer. We're not going to spend in the paper. We take some time talking about how we can address some stylized stacks, but we're going to be related to those stylized stacks. We're related to some theoretical work on search frictions in trade. Rausch has written a couple papers about this. The New Consumer Margins by Arkalakis, and then the newer paper by Eden, Court, and Kmartz. I see Jonathan's joined us now. We're also going to be related to some of the empirical work and facts in regard to search in trade models, and we're definitely related to this rising literature, sort of structural micro level models. Allen's job market paper, Eaton, Slava, Jenkins, Kazan, and Tybout, right? These models take the micro features between matches very seriously. They estimate them carefully, and then they get predictions of those models. Our paper is going to be a little bit different. We're going to gloss over a lot of those micro features and go for some of the aggregate predictions. Okay? We're also related to goods market predictions and macro, and there's a nice recent survey by Bernard and Moxness about search and matching in trade. Okay, so because the model is pretty, is there a question? No. Okay, because the model is pretty, involved, I want to provide you with a quick overview, and in the slides here, I've tried to pare down what I have to show you as much as possible. Right? So we have a standard Mellis-Chenet style trade model on the trade side. Exporting producers have some exogenous productivity indexed by VARFI. That's going to come from a Pareto. We have a representative consumer with Cobb-Douglas utility over a homogeneous good. We'll label that QD1. And the CES aggregate differentiated varieties that come from a bunch of different destination origin pairs, right? So product comes from origin O and is consumed in destination D. That's how we keep track of these subscripts. We're going to assume that the share of expenditure on the differentiated goods up and down by the Cobb-Douglas utility is alpha, but the differentiated goods have some elasticity substitution sigma, and that's obviously going to give us a differentiated goods ideal price index and overall ideal price index. We assume that for the firm side, we assume that total production costs are constant marginal costs and a fixed period cost, right? So this also looks very similar to a lot of the trade models that we're used to working with. Here, the only input is labor, right? That's the W in that expression. I'm not sure, can you see my little hand? Okay, so little W, right? And then there's an iceberg trade cost as well. There's no frictions on the input side, and there's no underutilization of resources in the economy in equilibrium. And so all labor is always employed. The search frictions are on the output side. Okay. But the search side of the model, we're going to use endogenous random search between retailers and producers. This is, pretty standard framework in the labor macro literature. Producers, we're going to assume that producers or exporters are going to access consumers only via an importing retailer, right? So they have to go through a retailer before they can access the consumers. We haven't provided a micro foundation for motivating or forcing this to be the case in equilibrium. We sort of impose it, but you could do that if you allowed an outside option where it was just more expensive to access consumers without going through retail. Okay, so the fundamental way to think about these search costs is that it takes some time and expense, right, for producers and retailers to find each other in a destination origin market. So we're going to segment our markets by destination origin pairs, which is also a common assumption in trade. So there's sort of like a German US search market, and then there's a US search market. And the producers and retailers are bouncing around in that market, trying to find each other before they can sell to consumers that buy varieties from that market. And those consumers live in only one big domestic market indexed by D. Okay, so some other assumptions. There's full information. So everybody knows everything. There's only one source of uncertainty And I'll explain that in a second. And it's not sort of like shocks over time or anything like that. Separations are exogenous. And as I said before, labor is the only factor of production. That's a frictionless labor market. Okay, so key quantity throughout our model is going to be the matching function. The matching function is going to be given by this function up here. It takes the instantaneous number of searching producers. So let U be the fraction of producers that are searching, and N be the number of producers or exporters that are searching. V here is the fraction of retailers that are searching, and N is the fraction of is the number of retailers that are searching. Okay, so it's going to take the number of each of those two parties and turn that into the number of matches formed in that instant. It's a continuous time model. Because this is a constant returns to scale matching function, right? We're able to characterize everything we need to keep track of in terms of market tightness, which is just the ratio of the number of searching retailers to the number of searching producers. Right? So this is going to look exactly like the labor search literature.
Okay. So may I ask a question?
Yeah, go ahead.
Yeah, so here the sellers are present in the matching function, but not specifically to a destination, and equivalently for buyers.
So the kappa, so the market tightness is going to be different, potentially different for each destination origin market. Is that
Okay.
right? So
okay.
while the number of retailers, right? So the number of retailers in the U.S. NMD, right? That's going to be some number. The tightness in each of these like products from these different countries markets is going to differ.
Okay. I think so the exporters aren't choosing to be present in a particular destination, though.
They will be, but that'll come up. That'll be
That is because of your notation. You've kind of distinguished one thing as a product of two things.
Oh, okay. The U's. I guess I don't know what the U's
Yeah.
are yet. I'll shut up. Yeah.
Okay. Yeah. Okay. So the contact rate. So the rate at which retailers meet producers is this transformation of the matching function, right? Key kappa. And the contact rate for producers is kappa key kappa, given by this equation. As the number, right, you can see that the matching function gives us properties for how changes in the number of the counterparty or of the same type is going to affect the matching rate, right? So take producers as an example. As the number of retailers increases, holding all else fixed, kappa DO is going to increase. And that means that producers are going to find partners faster, right? So the people or the type of agent that you're searching for, you're going to bump into them faster as there are more of them that are searching. Okay. The producer's value function, and this I think will help address Jonathan's question. Okay. So it's a continuous time, right? So the producer's value function is given by this asset equation. So the value of being in a relation, there's three possible states for the producer, okay? The value of being in a relationship, XDO, right? So this producer has a certain variety, bar fee bar, is given by XDO, and that is, they can either take that value and sell it and invest the proceeds at the risk-free rate R, right? Or they can operate and sell their product at a negotiated price N, sell Q units of that product, pay a production cost, a period production cost of T, right, which I showed you a couple of slides ago, with a per period fixed cost F. Then they're hit with a exogenous Poisson rate shock, lambda. The relationship is destroyed and they lose the capital value of being matched, but get the capital value, the present discounted value U, of being unmatched, an unmatched producer, okay? The value for a producer of searching for a retailer is defined by this equation, the second equation, right? So the producer faces a search cost L. They have to pay every instant. And then at Poisson rate kappa he kappa determined by the matching function on the prior slide, they meet with a retailer. Then they get the capital value of forming the match, right? So they go from being an unmatched producer, getting value U, to getting value X. And they have to pay a sunk cost S, right? But you only have to pay the sunk cost when you set up a relationship. You have to pay the search cost when you're searching but unmatched. You have to pay the fixed cost F when you're matched, right? So these are the three main types of search costs or types of costs, additive costs that we use in international trade. Now there's another state, right, which is actually, it can actually be pretty important for these search models, and you can get intuition from that by thinking about the labor literature. There's a value of being an idle producer. We're going to keep that really simple, right? We're going to say that if you're not even looking for a partner, you get H per period. Okay? So obviously, if we just omit this state and we pay somebody 0, right, for not searching, they could find it more valuable, right, to search than to, more valuable to stay idle than to search. So there's a particular constellation of parameters that it would eliminate the idle state, but it's not when the idle state payoff is 0. Okay. That's like being out of the labor force in the labor literature. You want to allow people to optimally opt out of searching if there's some sort of search cost each period. The retailers have a similar set of.
Andy, can you go back one second?
Yeah.
So I haven't understood. Is it one exporter matches with one retailer, or I can match with as many retailers in Germany as I want?
So the number of retailers is actually going to be immaterial. It's the number of vacancies, right? So you could okay. So it's the number of vacancies that are going to be pinned down in that.
I mean, I guess I was trying to understand like why when I'm unmatched, why that has any value. That's not just some free entry condition. And I thought you were somehow going to say that I was restricted on how many matches I have, so that even when I'm unmatched, I had some value. But now you're saying it doesn't matter.
The producer has, once the producer's matched, there's no incentive. Like there's no increase, right? So the producer of that particular variety gets nothing from matching with two sellers, two retailers in that specific market.
Why not? Why wouldn't I want to sell to Walmart and
well, you only need you're only going to need one retailer to access all the consumers you want.
Okay, so maybe it'll be clear with the next slide, I guess.
Yeah. Okay, so the importing retailer's value being a relationship with producers defined by a similar asset equation, right? So the retailer purchases quantity Q, sells it on to the final consumer at price P, and they're very simple, right? All they do is buy the product from the producer at negotiated price N. They buy Q units of it, and they just sell it on. They could also be hit with an exogenous shock lambda and destroy the relationship, lose the value of being matched, but get the value of being an unmatched searching retailer. Okay, so the retailer's value for searching for a product is given by this equation, right? So this is going to be the key search cost in our model. So there's an unbounded mass of potential retailers. There's going to be a free entry condition. We'll get to that in a second, the solution. But the key search cost is the search cost that the retailer has to pay. They have to pay C every instant that they are searching, and then at rate P kappa, they meet a partner, right? They don't know which producer they're going to match with. And it's obviously more valuable to be matched with a higher productivity producer than a lower productivity producer. So they take the expectation over all the producers that they might match with. Right? Inside that expectation, the retailer has the opportunity, once they see the variety that they've matched with, they can choose to keep searching, right? Or they can take the value of the match and lose the value of being an unmatched retailer.
Okay, this is all origin specific.
Yeah. Sorry, which part is origin specific?
Well,
Everything is in.
I see DO here.
Yeah, everything is
So I'm a
indexed.
destination B. I'm a retailer.
Yep.
And I'm looking specifically for suppliers from origin O.
Yeah, that's right.
I see. Is there any interaction across
In
sellers?
our model, there's no. In our model, there's not going to be. There could be, and that would
Okay.
give you quite a bit different model, right? If you had some sort of increase in returns and the number of matches or the number of markets you're matched to or something like that.
Okay.
But here we don't have it. And all of these, all the retailers are just very simple. Okay.
Okay.
Retailers, they have no productivity of their own in their setup, right? There's an unbounded mass of potential retailers, and all they do is buy the product and sell it on. They're like a consumer accessing technology. If you added more features, the model would get more complicated and potentially much more difficult implication.
Okay.
But Andy, they can reach all consumers in a country costlessly.
Sorry, who?
That's
the
retailers
right.
they can sell to everybody in the country. They don't have any
Yep.
costs of distribution or anything like that.
Yep. There's no
Okay.
new consumer margin layered on top of this.
Sure.
Although you could, right? Because
Well, I think that goes to my previous question, which is if these guys are limited in their scope in any way, then the manufacturer has really got to think about how many retailers he's going to have.
so each productivity, right, doesn't gain anything. They're going to be monopolistically competitive, right? So like as soon as you can access the consumers for your productivity, you don't have an incentive to repay the search cost to find another partner.
No, I guess what I was saying is if he could only access half the consumers, right, then you would still want to pay for somebody else to deliver the products to Rochester and Washington, D.C., right?
Okay, sure. So if you segmented markets further,
Yeah.
So yes, this is all going to be indexed.
He can sell everywhere at no cost.
Yep. Whatever your DO is. I mean, you still have the F, right? You still have the fixed cost, but all of these things are indexed by FDO. There's no increase in returns, which I mean, once you see like the implications of the model, I think it's going to be a feature, not a bug. Instead of, if we had increasing returns, it would be hard to tell if it's the search part or the increasing returns of the search model that are driving some of the results. Okay. So the solution for the model, right? There's two stages, right? And we'll solve by backward induction. So the second stage, within each match, we're going to have continuous match bargaining between retailers and producers, and that's going to determine the quantity traded and the negotiated price at which these two parties trade. And given that solution in the second stage, the retailers and producers are going to make a decision to search. So the producer's decision or remain idle is going to determine the productivity cutoff that looks a lot like the Melt's productivity cutoff. And then the retailer's decision to search is sort of the main equation that helps pin down the equilibrium market tightness. Because there's an unbounded mass of potential entrants and we allow free entry into the retailer search market, or free entry by retailers, that's going to be the main equation that pins down the market tightness. Okay. So the new equilibrium variable is going to be market tightness, KDO, right? So that's where we're going to differ from more standard trade models. And then we're going to be able to convert that into the fraction of unmatched producers in steady state. The key concept to keep track of, right, is that like any search model, we have a concept of unemployment, unmatchedness. And that fraction of product varieties is going to be, the fraction of unmatched product varieties is going to change lots of things, right? So these unmatched varieties can't be consumed and they're missing from all economic aggregates, right? There's going to be a mass of varieties. They're not going to be consumed, so they're not going to enter the utility function, so they're going to affect the level of welfare, they're going to affect the level of trade flows. And then if the mass of varieties changes with some tariff change or some other policy change, then the changes of all those economic variables is also going to differ from the standard trade model. Okay, so the key thing is that endogenous mass of products. Okay, so the second stage, they're going to continue. the two parties are going to continuously match bargain over the surplus. It's going to give you two conditions. The first condition is the quantity that maximizes the surplus is just marginal revenue equals marginal cost. So within each match, right, the quantity traded is completely unaffected by the search frictions. Okay. Basically, the two parties decide to choose the point on the consumer's demand curve that maximizes their profit. And that's the same that you would get in a model without search. Then they're going to bargain over the surplus using this, the price, negotiated price N to split that surplus. Now, we can derive, again, the pencil and paper nature, the analytical tractability of our model is really helpful here. So let's just derive this equation in closed form. Right? So we know that the negotiated price is going to split the surplus, and it's going to be equal to a convex combination, with this, the convex determined by gamma, between the final sales price and the average total production cost, less the outside option. So it's less the outside option because the retailer can force the producer to go back and look for another partner if they don't like the offer. And otherwise, it's just the average total production cost. So if you look at this expression for a second, if we remove the search frictions entirely, that means kappa goes to infinity. You find a partner instantly, and gamma collapses to 0. Negotiated price equals final sales price. Okay? If you set the bargaining parameter beta equal to 1, so that you let producers force retailers to do their bidding, the gamma will also be equal to 0, and final sales price equals a negotiated price. Okay? So we are going to completely nest standard trades with this search friction. And all I have to do is vary the search friction C in order to get back to a standard trade model. Okay. So given that solution to the negotiated price and quantity that's traded, stage 1 for producers determines the productivity threshold. The binding productivity threshold is going to be the cutoff between which a producer decides to search or to remain idle. There's another cutoff, but it's not the binding lower cutoff between taking a match and searching. We have that in our appendix. After a bunch of algebra, you can show that this condition up here, the value of searching being equal to the value of remaining idle at some bar phi bar. You can show that the bar phi bar that equates that is very similar to the cutoff that we would get in a standard Mellon's model. So it sets the flow profit equal to an effective entry cost, where the effective entry cost then takes the all of these standard terms, or say the other additive costs that the producer faces, right? So the standard Mellon style model would not have these 3 other terms; it would just have this F. Okay, so that's the fixed cost each period that's paid. But then there's a appropriately discounted search cost that the producer would have to pay. And there's an appropriately discounted opportunity cost of leaving the idle state. And there's an appropriately discounted sunk cost, right, of forming a match once you bump into somebody that you want to match with. Right, so this provides a nice micro foundation for what entry costs actually are. It nests the standard model, right? So again, if you set the search cost C equal to 0, kappa goes to infinity, and these 2 terms disappear, just leaving it with the fixed cost and the sunk cost for the effective entry cost. And it is going to endogenize the entry cost. So if the rate at which you a producer finds partners is higher, the effective cost they have to pay is lower, and that makes it easier for certain exporters to get into that market. It lowers that cost. Stage 1 for retailers, right? We take the value of search for the retailer. We're going to allow free entry from this unbounded mass of potential retailers. They're just going to crowd into the market and drive the value of posting another vacancy to 0, right? And that's going to imply, after some algebra, that the expected cost in equilibrium, the expected cost to a retailer of searching for a producer is going to be equal to the expected benefit to a retailer of searching for a producer, where this cutoff is the same cutoff I showed you on the prior slide. Okay, I'm going to show you 2. That's basically the model and like a quick run through of the solution. With only an hour talk, I couldn't really provide more details. We're going to look at a couple equilibrium quantities before we move to some implications. All right.
Andy,
Yeah.
can you just talk about the assumption here that the manufacturer can't open up its own retail shop? That seems kind of, with the free entry condition, it seems like the efficient thing to do is for me to pay my own. I mean, I just can easily go into the other country. So yeah, I'm a little bit, I'm trying to wrap my head around that assumption. Why they're not doing that.
So, you know,
seems like you want to internalize everything here.
In full transparency, we don't allow that, right? So that's the
Okay.
first reason. The second reason is, I think, you know, in the data, we see a lot of intermediaries, right? We see a lot of like retailers getting products from producers in foreign countries, and fewer, although you know some, directly accessing consumers. And then you know, you could support this equilibrium by allowing the producer to have an outside option that was more expensive than using this technology to access consumers.
Okay. I mean, I guess the other interpretation is just there's another set of costs, and there's actually not free entry into the retail sector.
Not free entry into the retail sector. So, okay.
There's a limited set of retailers who can kind of search as much as they want, but you can't actually enter that sector. So it's not really a free entry condition, just a free, you know, there's just search amongst a limited set of firms.
So as long as this cost C captures like the present discounted value of setting up a new store, then we're good to go.
Okay.
Right. So, you know, in this stylized version, we say it's a search cost, but if it's like, you know, you gotta whatever, buy a piece of land and build your store, and then you gotta like search for a product to put on your shelf, we're still okay. Okay.
Could you motivated by something like the retailer keeps getting more and more products through this kind of process, but it has some fixed cost of existing, so that that's very efficient for it to be the one doing it, rather than in George's situation, you have to be one product, set up a firm to just retailer to just sell that one product, which wouldn't sound like a very good thing to do.
Sure, I think that sort of setup would totally rationalize this. We have a section in the appendix where we talk about restricted entry, right? So here we use free entry where the value is driven to 0, but you could set the value to 6, right? Or 12, or you know, any number, and you're going to get very similar implications. And then we have a section in the appendix where we actually prove that the only with free entry, the only cost that can be supported is a C. Okay, so we're gonna keep track of something that looks like, I'm gonna have to speed up a little bit, make sure I get in under an hour. So we can calculate a concept that's like so it's gonna be like the labor force adjusted unemployment rate, right? We take the fraction of producers that are searching and divide that by the fraction that are trying to find a partner, 1 minus the fraction that are idle. And this is going to be the concept of the idle state adjusted unmatched producers. That's going to be the key ingredient in all these economic aggregates. The quantity is going to be really important, right? As it is in all trade models, is the overall price index. Okay? So the overall price index is given by this expression here, the differentiated goods price index, make it a little bit easier to look at. And the multilateral resistance term, rho, right? So a lot of the notation borrows from Chenet, 2008, has inside of it the fraction of matched producers, okay? So this is an example of a really important quantity, the price index, that's affected by the mass of matched producers. So we have the usual frictions, the tariffs, the iceberg costs, and the effective fixed costs, right? Then we have the mass of producers that are matched, are also an ingredient in this multilateral resistance term. It's going to ensure that the price index, right, if there's any search friction at all, so the price index is going to be higher, because there's a mass of products that are just missing. And then if this mass changes when we change something, the price index, the change in the price index is going to be different than it was in the model without search.
Okay, so the sellers from different countries are competing with each other at the retail stage. It's just that they're not interfering with each other at the search stage.
They're competing with each. So,
Because
sorry, which one?
the price
Right.
index here, you're summing over all origins.
Yeah, the overall, yeah, because of the utility function, the consumer has utility over products from all origins. And so this is
Right.
and so they would love to consume every variety from everywhere, but they face the usual iceberg and fixed costs or effective fixed cost barriers. And now they face a search cost barrier. And the way the search cost barrier changes the price index is the mass of products that are matched.
Yeah, so I guess the distinction I'm making is in the price index here,
Mhm.
we're summing over all the origins. So that's the sense in which sellers from different origins are competing with each other in the price
Yep.
index.
I
But in what
understand
you've
your
shown us
comment now.
up till
That's right.
now, they're
Yep.
not getting in each other's way
That's totally right.
in the search process.
Yeah.
Okay.
So to restate your point, there's definitely interaction across markets, across destination origin pairs, via caused by search frictions. But it's in the usual way that we model a lot of these interactions in trade. It's through the economic aggregates. There's no direct increase in returns. There's no direct competition in the search market. All the interaction is coming through the aggregate variables. So certainly when the overall price index is different, then the ability to the profit that you can make is going to be higher or lower, et cetera, et cetera.
Sure.
That's right.
But the feedback is through the price index, not
The feedback, that's right. The feedback is only through the aggregate variables. That's right. You can analyze every search market individually, and then given the aggregates, right? And then add them up. Okay. Okay. So that caps the base of the model, the solution, and a couple of the most important quantities that we're going to need to keep track of. Now I'll show you some of the analytical predictions of our model before we move to the numerical application. Because the Diamond-Morrison-Pizzarides model is so straightforward, and the Melitz-Chenet-Hoppenheim models are so straightforward, we can get in closed form a gravity equation, right? I mean, we needed to do the CES assumption and also the Pareto assumption, but we can get in closed form a gravity equation that's consistent with these search features. Okay, and what you have to do. What you have to do is you have to add up the right. You have to take the fraction of producers that are matched times the number of producers, right? So this is like the search friction adjusted number of varieties, and then the value of all the exports for all the guys that are above the threshold, right, and able to export. One thing to notice is I have to use the price N, the negotiated price. That's the price I'm going to observe at the dock, right? That's the price that's negotiated between the producer in the foreign country and the importer in the domestic country. I can't use the final sales price P. Okay, so these two things together are going to give me a gravity equation that looks, in black here is the standard gravity equation that you would get from this model. And these blue terms are the additional terms generated by the search frictions. The first one is the mass, right, of unmatched exporters, which is always less than or equal to 1. Okay. And the second term is like a markup term. So because we have to use the negotiated price, which I already showed lies between the, it's a common use the final sales price and average production cost, there's some markup term that also reduces trade flows. So trade flows in this model are lower than a model without search for 2 reasons. And then the endogenous nature of the effective entry cost is also going to have an effect, but the analytical expression doesn't differ. Search frictions are going to attenuate the gains from trade. Right? So if we make the same assumptions that Arkelakis, Rodriguez-Claire made in the 2012 paper, we can calculate the change in welfare in response to any foreign shock as this expression. And so this is the expression that you would get from their model. And the new part is that you also need to keep track of the change in the domestic match rate raised to some parameters. And we can show that that this term always ensures that the change in welfare in response to any foreign shock in a model without search frictions is larger, right? Because this term has to be greater than 1. Okay, so for intuition, how does this work? Well, let's imagine I'm increasing tariffs. So the US increases tariffs on China. That's a higher price index in the US, which increases the value of being a matched US retailer, right? And that raises the number of retailers that decide to enter in the US, which increases market tightness and makes it easier for US producers to find partners. Right? So there's an additional protectionism effect in the search model, as long as the change in the match rate is endogenous. Okay, so to say it again, when if the US protects its market by raising tariffs on some foreign market, it becomes more profitable to be a retailer. So retailers enter, and that makes it faster, right? More chance that you bump into a partner if you're a US producer. And that reduces the loss from welfare caused by raising the tariffs in the first place.
Andy, this is the steady state result?
These are, so yeah. So
This is
all
the
of
new
this,
steady state.
Yep.
Okay.
All of this is, we haven't started yet, but we're going to work on an extension to add a steady state transitions. But everything I show you is steady state. Okay, so even though the welfare changes are attenuated, the trade elasticity, the import elasticity, is higher. Okay? And that's because intuitively, I basically introduced a new margin of adjustment, okay? A matched margin. I also introduced a markup margin, okay? But it'll turn out to be, in our calibration, the most important one is the matched margin. Okay, so let's go through some. The standard elasticity would be this negative theta term, but then we have two additional terms, right? So, and I'm using the normalized trade shares. The elasticity of the match rate in the destination origin market, the elasticity of the match rate in the domestic market, and then the markup terms in each of those, how those change when you change tariffs. Okay, so for intuition, right? If you raise tariffs, if a domestic market D raises tariffs on O, that reduces retailer entry in that market, right? It's more costly to get those products. So there's more unmatched producers in DO. Right? So this is negative. The effect here, if you raise the same tariff, right, and there's a higher price index that increases the value of being a retailer. So when the value of the retailer to the retailer goes up, more retailers enter, the finding rate goes up, and that increases this number, right? So this change is negative, this change is positive, and it enters with the negative stuff. And then these terms are going to be similar. Okay, so the elasticity is always going to be, trade elasticity is always going to be more negative in our framework with endogenous. Notice you need to have endogenous search. You have to have the mass of products changing endogenously. If all these terms are fixed, then they disappear and we're back to the standard. Right? If the mass of products that are matched is always the same, then any of these, the tariff changes won't have any effect. We can show that by taking the total derivative of imports with respect to the search costs, we can also show that search frictions are going to operate mainly through the extensive margin. Okay. So if you do this very involved derivation, you get, you can decompose the change in imports into an intensive margin and extensive margin. You can then decompose the intensive margin into a final sales elasticity, right? So how final sales are changing and how a markup is changing, the import markup is changing. you can decompose extensive margin into the threshold elasticity, how the mass, the cutoff is changing and how that's affecting trade flows, and then how the fraction of producers that are matched is changing as the matched elasticity. Okay, so this expression is hard to look at. I'll show it in the table. I'll show you all the terms in the table once we get to the numerical results. But if we assume that all these, GE effects are zero, we're going to be left with this term, which we can approximate as the fraction of matched producers, the fraction of unmatched producers times this function of the elasticity of the matching function. Okay. So a very clear prediction for how trade should change when we change search cost. Okay, so we're going to take this model to the data by solving this minimization problem. Okay. This is a mathematical programming with equilibrium constraints problem. Okay, so we have our objective function is a bunch of moments predicted by the model, right? Evaluated at parameters in big omega and endogenous variables, big phi. And then M is the moments in the US and Chinese data. Okay. There's some equilibrium conditions, right? So we have to solve for the equilibrium and all the equations that I showed you. And then there's some nonlinear equilibrium and parameter inequality constraints, such as sigma has to be bigger than 1. Okay. Okay, so solve this problem. These are, we use some parameters are externally calibrated, right? So like the bargaining power, beta, we fix that at 0.5. We take the elasticity substitution to be 4. Pareto shape parameter can come from like Axel's estimate and implied by this elasticity substitution. Then, given those numbers, right, we're going to solve that minimization problem, and we're going to get a whole bunch of internally calibrated. We call them internally calibrated instead of estimated because we don't have any errors in our model, right? We just have a model. I didn't show you where our model could go wrong. We are over-identified, but we don't have any errors. So we treat this as like internally calibrated parameters found by minimizing that difference, and then the externally calibrated parameters. Okay. Get the results. So here's the model fit. This shows the moments that we use in the data on the data column, and then the implied moments at the solution from the model. So I'll mention a couple important ones, right? So we're going to target a log linear input elasticity. So that's the elasticity you would get from running a simple log linear gravity equation with fixed effects. That's going to be particularly important for informing the matching function elasticity. Okay. Then we're going to use the percent of US firms that are exporting to China, right? And the US manufacturing capacity utilization rate as measures of sort of the matched rate in 2016, which will be informative for the search cost C. That's so important for a model. Okay. Using those parameter values, right? I'm going to show you what happens when we change our search our international search costs. Okay. So we start with the baseline in column 1, and we're going to reduce the international search cost, so the cost of a retailer finding a partner in the foreign market, down to the cost that they face if they're searching for a partner in the domestic market. Removing all search frictions, we also have that in the paper, but and those magnitudes I think are reasonable, but we thought that this is the most informative exercise. So not surprisingly, if you reduce the search cost, right, in the Chinese US and US Chinese market, the fraction of producers that are matched increases a lot. Okay. Now, how does this affect the things that we care about? Well, the match rate goes up a lot. We're getting a lot more varieties. from China, and China's getting a lot more varieties from the US, right? So Chinese imports from the US go up a lot, like 600% and 450%. Okay. The price index, right, for goods from the Chinese price index for goods from the US, and likewise the US price index for goods from China, declines by 50% and 40%, right, by a lot. And then these altogether, right, reduce the US price index. Right? We removed the search friction. We reduced the friction in the model. So allocated efficiency has increased, right? And the price index in each economy has declines, and therefore US welfare goes up by 5.6% and Chinese welfare goes up by 4%. Okay.
It might be nice to compare that column to some very standard model where you did the same thing and just kind of eliminated the iceberg costs or something. Okay. Just as a point of comparison. I mean, because one thing you've done, I guess, I might have missed something, but you're sort of making the search friction do the role of what a iceberg cost would normally do. And then you're showing us what that does, but it might be, yeah, interesting to see if it does different things.
So we have a table in the paper that does that exactly. Basically, for a 10% change in tariffs, what change in search costs do you need to consider to get the same change in aggregates and the same boost of welfare? I didn't include.
I think. Sorry.
The other thing, this is a little further from what you've done, but you talked about maybe thinking of the dynamics later. But it seems like one of the interesting points would be to see if you could capture something like in Kim Rule's job market paper, where there's sort of a delayed effect through the getting the matches all sorted out again. That would be pretty neat.
No, the unmatched rate, just like in the labor literature, right? The mass of products that are matched is going to adjust slowly. Right?
But in the labor literature, it sort of adjusts too fast, right? So I guess
compared to the data, right?
Yeah, whether you can get some pretty good action out of this mechanism.
Yeah, that in the labor literature, that depends on the model you use, but a baseline Mortensen Pissarides model in the labor literature gets adjustment that's too fast. Here, the baseline search model might be perfect.
Yeah.
Stay tuned. Okay. So using our now, I want to show you the compare the change in welfare, right, in response to a 10% change in tariffs in a model with search and without search. So column 1 does the decomposition for the change in welfare when China raises tariffs by 10% on the US. Okay, and so we keep track of all the quantities, right? So they raise tariffs, and so the domestic consumption share goes up, right? To about goes up by about 10%, right? So that means the domestic consumption share's effect on welfare, right? It lowers welfare to about 98.5% of its prior value. There's obviously, this model has no search frictions, so none of the match rate terms change. The change in total consumption is trivial, and therefore the change in welfare is about negative 1.53%. Okay, 1.5%. Now, in the model with search frictions, do the exact same exercise. First, I'll point you to these domestic match rates effect on welfare. Right, so this was the prediction that we made theoretically. It says basically that this entry here is positive, right? And that's attenuating by a small amount, right? But it is going to attenuate the change in welfare through this protectionism effect on the search market. Now, what we couldn't show theoretically, because if all you can observe is the domestic consumption shares, you can't accidentally predict how those are going to change without knowing all the other parameters. But you can actually see that the domestic consumption share changes by much less, in the model with search frictions than in the model without, right? This is because in the model of search frictions, right, we start out with a price index that's higher, okay? And then when we change tariffs, only the varieties that are matched, this is a looser statement, right? Because there's a lot of derivatives in here to get it right. But intuitively, only the varieties that are matched are the ones that are going to be affected by the tariff change. And that's a much smaller set of varieties than if we have no search frictions at all, right? So the change in the price index is less sensitive to changes in iceberg costs when you have search frictions. And that's the fundamental driver for why the change in welfare in the model, the ex-ante change in welfare in the model with search frictions is so much lower than in the same model without search frictions. Now that result, that's for the ex-ante welfare. Right? For ex-post welfare, to do exercise like the ACR work, if we see a change in trade flows, right, or import shares of 1.8%, what sort of change in welfare would we interpret that to have been? Right? And we know we need two ingredients to do this using the ACR formula. Right? We need the change in import shares, and we need an estimate of the trade elasticity. But remember, I also told you that if the world is characterized by search frictions, trade flows are going to respond more, right, than in a model without search frictions. And so if it is in fact the case that the world is characterized by search frictions, we're going to overestimate the trade elasticity in a log linear import elasticity specification. And so we're going to understate the ex-post welfare effects. Okay? So let's walk through the table to hopefully clarify some of that. So using our baseline search frictions, right, and the numbers from the prior slide, if China raises tariffs by 10%, the change in import shares will be 1.8%. If we estimate ex-post the log linear trade elasticity, we would estimate about -6.5. Then we apply that to the 1.8% change in the trade share, and we would calculate ex-post change in welfare of only -0.13, which is about half the size that we know welfare actually changed in this model. And that's because we're using basically, we need the theta, we need the true structural parameter to get this welfare, ex-post welfare calculation right. But we only have, right, the one that's contaminated by all those other terms I showed you in the trade elasticity equation. And this result holds up even if we reduce the search frictions by quite a bit. Right? So using our baseline search frictions, the change in welfare is about would be estimated to be half as much as it actually changed. If we only use 50% of our baseline search frictions, right, it's almost exactly the same. It requires a smaller change in the unilateral tariff, of course. And all the way down to, even if we use only search frictions that are only 1% of our baseline value, that would only depend on a 2.1% increase in unilateral tariffs, we would still, substantially underestimate the true change in welfare by using the simple ACR formula. Okay, it's only when there's no search frictions are the two predictions going to coincide. Okay. So comparing the comparing the trade elasticity, the elasticity of the import shares in a model with search frictions and without search frictions, column 1, okay, as was shown in that expression. If there's no search frictions, it just collapses to the standard expression, and the trade elasticity would be equal to the negative of the Pareto parameter. Also, the trade elasticity and the consumption elasticity are the same. because there's no negotiated price, right? The price that the consumer pays is the same as the price at the dock. But in our model, right, we're going to have the first effect, right? We also have the Pareto shape parameter effect. But now, and I've included all the terms from that big expression, but the biggest one to keep track of is the elasticity of the Chinese-US match rate. Right? When China raises tariffs on the US, right, they penalize their domestic retailers, and they have a significant impact. They reduce a lot the number of matched varieties, which makes the trade elasticity much more negative, right? And in this calculation, it's 2.12 more negative. So that the overall, the trade elasticity goes from negative 3.2 to about negative 5.5. Now, I mentioned that there's also that effect of the markup term, the fact that the negotiated price is the thing that you're going to see trade flows at, but the final sales price is going to change in some different way. But in this calibrated version, the markup term doesn't change very much. And we also show that the markup term, this negotiated price final sales price term, has to be bounded, right? That the markup the markup that the retailer gets can obviously not be bigger than the total markup between the production cost and the final sales price. Decomposing the trade flows.
Andrew, we should probably wrap up reasonably soon.
Okay, this is my second to last thing. Decomposing trade flows into intensive and extensive margins for these three main barriers to trade: the search cost C, the iceberg cost tau, and the effective cost F. We can see that search costs operate mainly through the extensive matched margin, right? Which that's not surprising. It's mainly by changing the mass of varieties that are matched that they're going to have their effect on trade flows. We can also see that that approximation I showed you works remarkably well. So using our calibrated model and with the matching elasticity. Okay. We can also show that which is just a restatement basically of the fact that the trade elasticity is much different. The iceberg elasticity is much different, but we can say that the operative margin is the extensive margin, and particularly the matched margin. We can also say that the changes in the fixed cost, right, or the effective entry cost, are still very small. Right? They have pretty small effects, even in the model research. Okay, so yeah, we have pencil paper framework. We're working on some extensions. We think we can say something about, Roush's differentiated versus homogeneous goods statement, that search barriers might have an effect on the pricing there. We already talked about extensions to dynamic frameworks. We think we can lift a lot of the prior work in labor macro, right? And look at endogenous separations. Those could be modified by, there's the closet, by learning, or the fact that more productive firms are more stable relationships. And we can change the matching protocol, right? So we've used Nash bargaining, but we could extend to non-sequential search or price posting. That could have different implications than the framework I showed you today.
All right, excellent. Thanks, Andrew. So now we'll just open up the stream for comments, questions, follow-ups. Just go ahead and unmute and jump in.
So
go ahead, George. I interrupted you last time.
Yeah, it's okay. This is really interesting. I think the thing I was trying to figure out is what comes from having a dynamic model versus having search frictions, because I think most of the results that you showed for like the welfare gains in steady state are what you would get in a model with like a sunk export cost. Basically, there's going to be an entry, there's going to be a change in entry, and there's going to be a change in kind of the profit and labor share. So it'd be interesting to sort of sort out how they're different. One way of sort of getting at that is often if you set the interest rate to 0, then I know in like the dynamic models I've worked with that the ACR formula holds actually in steady state. So it would be interesting to see if that actually holds in your framework as well. Yeah, so I think should do a little bit more to sort of figure out what's exactly search versus just a dynamic decision. I think the new part here is, the really new part is how the markup is endogenous, right? That's different from like a sunk cost model. So maybe just a comment.
Yeah, thanks, George. So the key is really the fact that the mass of matched varieties is endogenous. So so a framework with sunk costs or something that could give you something like that would have predictions that look like what we have. But if you have a model with sunk costs and you're analyzing it in steady state, where the sunk costs, don't change the change in some endogenous variable that isn't already included in like the ACR type expression, then I don't think it will have an effect. That's really if we basically wrote down the same search model but had constant contact rates, then all the stuff I said about changes would disappear. I don't know, did I lose George? Maybe. So the trade elasticity, okay, like if the contact rates are constant, then the trade elasticity is the same as standard trade model, the ACR expression is the same as standard trade model, et cetera, et cetera, et cetera. The levels of everything would be different, right? But if the contact rates are constant, you won't get like most of the interesting things that we have. You have to have endogenous contact rates. So yeah, a model with sunk costs, if it has that feature, would look like very similar to ours.
Yeah, I mean, I think it would look very similar. I think again, the big difference is the pricing formula. That's gonna be different. So, and we can talk more about it. I would try to sort of see like what's really the different part. And one way of looking at that is taking the R to 0. So yeah, that should be an easy thing to do.
Yeah, the part where I found it a little hard to follow was when you were talking about the effects on welfare and the effects on the trade elasticity, because you said your model makes the trade elasticity larger in absolute value, and that it also makes the welfare effects larger. But then the ACR formula, those couldn't go in that direction. So that's just a little confusing in terms of presentation, I guess.
Yeah, it's the ex post. Yeah, I'm sorry if that wasn't clear. It's the ex post versus the ex ante. That's the key.
What do you call it, ex ante and ex post?
So one is like, are you making a prediction? Fix all the parameters. Why am I calling it? Or how am I distinguishing between those two?
Yeah, I missed that.
So the ex post is you get to observe the change in the endogenous variables, and then you try to back out some the welfare. Whereas ex ante is you only fix the parameters.
Yeah, you're kind of calling ex post more the ACR philosophy, and ex ante is like the Melitz and
that's right. The ex ante is like yeah, exactly. Ex ante is like the one you would want to know for policy. Ex ante is like the
yeah, that's how I always have a hard time thinking about when you want to do the ex ante one, but the ex post.
So it's sort of like the structural. Maybe that helps. Like if you have the structural model predictions would be the ex ante, and the ex post would be you already saw how much the trade share changed.
Yeah.
And now you want to figure out what the welfare effect was.
And so that part's just hard to follow because it's not clear which one you're doing, and then they're kind of going in funny directions depending on which way you think about it.
Right. No, that's right. It is. It's confusing that they go in different directions, and they do, and it's because the trade elasticity is much larger in absolute value in a search model. And so if that's what you're using to raise your domestic consumption share to calculate the ex post welfare elasticity, you're going to underestimate the welfare effects.
I was a little confused about retailers. Did you say there was an entry margin for retailers as well?
The entry margin is because the entry margin is captured by their decision to post a vacancy because of the free entry. So there's no separate entry decision.
Okay, so is the mass of retailers fixed?
Unbounded potential mass.
But does the set of so they're all either possibly doing nothing.
Yep.
Okay,
They
now will one retailer ever match with multiple sellers?
So the number of retailers is immaterial. It's really the number of vacancies that you have to keep track of. So think of it this way. We could have one enormous retailer deciding to post another vacancy, or you could have one retailer with one vacancy and have tons and tons of retailers.
Okay. So it's really, so vacancy here is just.
It's like an infinitesimally small slice of shelf space.
Okay.
And I'm going to put my product on that shelf. And so that could be in one enormous store, or they could have like,
okay. And there's a cost to becoming each vacancy has a fixed cost, and that's the margin at which things are adjusting.
Correct. Exactly.
Yeah. I'm with Sam on this. I'd probably just think about that as a search cost for matching as opposed to some entry into the retail sector.
Sure.
Because then this thing where like I can't distribute myself doesn't become an issue.
So say that again. So that's just like
the issue, that I can't pay C and distribute myself. I think you really want to think about this as just the vacancy post, the opportunity, the matching function for finding these two types of guys, but whether these guys have, I don't think you want to think about it as a free entry decision into retailing.
Oh, I see what you mean. Sure. Yeah.
It's a free entry into like matching, right?
Exactly. It's a free.
That's all.
Free
you don't need to
a
say
vacancy.
that. Yeah.
Got it.
Yeah.
So totally right. Yeah. Okay.
So it would it'd be interesting to me, like so there's this paper by Droz and Nozal a few years back. To see whether that framework actually nests into your framework. In some sense, they have the pricing, they have the matching, and so very
closely related. Mm-hmm.
So I guess the different part is the heterogeneous firm part, and what you're actually getting from the heterogeneous firm part relative to the pricing and the different elasticities. That would be useful for me to sort of see what that's giving you.
So okay, it's like we're definitely closer to 2012, right? Yeah.
Yeah. Because they have the bargaining, and they also had
Yep. So one is going to be this one, right? Which is something we care about in trade. So the fact that now we have like hopefully labels on some of the things that could make up the barriers that determine the set of producers that decide to try to find a partner and those that don't. So there's both they're taking into account the cost they're going to have to pay every period that they're serving the foreign market, and if they have to search to find a partner, and the opportunity cost of doing whatever else they could do with that capital, or the scrap value of the firm, or home production, or whatever, and a sunk cost as well. Right? So I mean that's something that I think we learned. That I think for me, the other thing we learned by writing the paper is that which I mean now in hindsight is pretty obvious, that the binding search cost is not the L, right? The important search cost you have to keep track of is the C. It's the search cost that's on the side of the market where there's a unbounded massive potential vacancies. Right? So we wrote down the model with an L so that the producer also has a search cost. Right? But that just like shows up as any standard trade model. So it's, you don't really with this, it's a particular setup, but with this particular setup, you don't care about producer search costs. You care about the retailers. Whoever has the ability to create new vacancies. That's the binding search cost.
But in some ways, with the L in there, you don't need the F anymore.
Right, with the L or with the S.
Way to think about what the F is or something like this.
So yeah, you could set, these numbers to 0 or different numbers to 0 or numbers equal to each other, and to define different, like in some of our experiments, we set L equals to -H, right? And then you're left with a parameter for the effective entry costs, and unendogenize the effective entry cost.
In our paper, Cornum and I did with Cremars, with the French data, we found there were a lot of regularities in terms of how entry by individual firms varied with market size and market share.
Yep.
I'm just curious if your model makes any prediction about those margins.
It's gonna, so we didn't, we don't have access, so let's see, you'll be able to see in the gravity equation. So and for this paper, we wanted to get some of the aggregate implications. But because putting these two frameworks together gives you predictions that look very similar to some, like your model, I think a lot of the results could be related. You might just attribute them to different terms, right? So
it'd be interesting to do some decomposition. I mean, if you looked at like just two different origins, O and O prime. O prime has a bigger market share. How much of that is due to more firms or more sales per firm?
Yep. So, or like I went to this slide. It's been a comment about like average exports, right? Like average exports are going to be, or average imports, average exports for market O can be the gravity equation divided by the number of producers, right? Which is basically going to be the mass that are matched times the number that exists. So a lot of that stuff, a lot of the search friction stuff, in some expressions that will cancel, and in other expressions that just simplifies. So you're left with it. But no, you can definitely, because the model is tractable, you can definitely relate things like trade flows, average exports, to other things that we've seen, right? So like distance and market share. You can derive all types of those expressions.
Yeah, I guess, but you have both the taus operating and the kappas operating in a bilateral level.
Yep. Yep. So you can't, without some, and I mean, so tau will obviously affect the match rate as well, because this is endogenous.
Right.
So you have to kind of decide, but some of the things that we might have attributed, some of the regressors in like a log linear gravity equation that we've attributed to, say, fixed cost or iceberg cost before, maybe they're actually entering in as search costs. So like language, why should language be an iceberg cost? Right? Or why should language be a fixed cost? Maybe language is better modeled as a search cost. And if you make language, if you make that C a function of language, it'll pop into the gravity equation in here somewhere. And that might help us disentangle like which ones are actually tau and which ones are actually like affecting trade flows through the fraction that are matched.
All right, so it's already 20 after. So I think we'll go ahead and close the official stream. You can stop the recording.